Are you a coder who gets rejected based on no practical experience or because others have a strong LinkedIn personal brand and you don't? Your coaching institute will hate me for doing this, but I welcome you to Code to Career 30 days challenge where I have chosen these 5 total strangers out of my LinkedIn contacts and have taken up the challenge to help them go from jobless or underpaid to well paid job, that too without additional degrees and certifications in the next 30 days. If you are a coder and wants to get a well paid job, this is your golden chance to experience real project implementation from scratch that gets you a well paid job and builds your LinkedIn personal brand and also resume for absolutely free. So why just watch? Get into our WhatsApp community to experience this. Link is in the description. Now let's get started.
So welcome all to this 9th session of our Code to Career Challenge Cohort 3, where we are talking about how to implement TFTP server, a very lightweight TFTP server, but as per the RFC. And going forward, we will actually port this server onto one ARM platform also, an embedded platform, and also we will adopt something called a service-oriented architecture in the last 2 sessions. Today, we are here to talk about something very important. The question is like this. So before I get into the what we are going to talk about and I share my screen, let us say the client has a very big file, very big file. Maybe I would say 1 GB. Yeah. Or few MBs, let us say 50 or 100 MB, 200 MB. When I'm sending only 512 bytes, how long do you think it will take? Even if you imagine a very fast network where the server and client are distributed and the distance between them is maybe 200 kilometers, 300 kilometers, you are in your hostel room. So your department server, which hosts some of the documents and assignment that your professor uploaded, and you are supposed to download it. Very big file. And you are in your hostel room with a network which is decent enough. Now you started downloading it. Now, are you the only one who will start downloading?
No.
There'll be so many people. So there is already a choking that is happening at the network level. In that case, what should be done? You can state the obvious answers. You can think something what can be done as an improvement or an enhancement to the plain TFTP specification. From the basic of increasing the throughput of a network to the protocol level. Any answer that you think I want to hear. This is a time for you to really think out of the box and understand what can be done. What do you people think?
Can you just repeat the question about the main point, because I didn't get the whole picture?
When there is an issue that you are downloading or uploading of a file, when the file size is very big, and I gave a scenario wherein you are in your hostel room downloading or uploading. You want to download the assignment sheet and you did the assignment, you have the soft copy and you need to upload for the professor to verify. And the same network is used by so many students for their reasons. And the file size happens to be a very big chunk, maybe few hundred MBs. But we know that every TFTP packet is only 512 bytes, right? Taking 512 bytes and transferring those many number of bytes to or fro And in a network where it is already loaded with so many people trying to get the bandwidth, sometimes every time that some upload or download happens, TFTP time what may happen, right? And practically you cannot even upload or you cannot even download. So I am asking a question from the basic question answer to this thing, like, okay, obviously Vamsi, then the network has to be good enough. So increase the bandwidth, right? Make the network more better. From that answer to an answer wherein you feel that, can this be done in the protocol? What are all the options that you can think? If this is a question that gets asked to you in an interview, what will you say? Yeah, who will answer?
Increasing block size, I think, could help, but it will not cater, I think, all of the cases.
512 happens to be less compared to 300 MB, 400 MB, and each student doing that 400, 500 MB. And it may also happen that somebody will try some once and they will see that, array, what is this happening? And they will go for a retry. Multiple instances will happen, same file, because TFTP doesn't distinguish, right? In the sense that it only differentiates the transfers between using the TIDs. If it is the same file, why does it care? What do you think?
Like a way to reduce the number of, I would say, overheads like acknowledgement or something like that.
Okay. Let us think the overhead of the acknowledgement is removed. Then how do the server know or the client know that transfer has happened? And remember, this is a file and your assignments based on which you will get grades. Can you afford removing acknowledgement? I have no problem. TFTP has no problem. Network has no problem. OS has no problem. Your professor has no problem. But you have a problem, right? What else do you think? Chiranjeevi, what do you think? Snehal, what do you think? So let me, for other people who just joined, I am talking of a scenario wherein you are in your hostel room, you have your assignment done, or you have your assignment pending for which you need to download or upload. Both operations are needed. And the file size happens to be a big file size. With the 512 payload or block of data, sending so many amount of MB and multiple students actually trying to get onto the network to satisfy their need will put a lot of load on the network, and ultimately the TFTP timeouts will start happening. So I try to upload or download, it fails, I try again. And at some point of time, the server also will not have enough. So for all the people, the question is from the basic answer, which could be like improve the capability or make the network good enough, till what can be done in the protocol. What do you feel you should answer, or what do you think are your answers? Swaminathan, trying out different ACK protocol instead of stop and wait like windowed ACK. Okay. Can you elaborate? Imagine for a moment, this is a question that is asked. See, you put this project. It has the essential.
If you want to work with me personally, where I guarantee to work with you until you secure a well-paid job, book a one-on-one call with me. Link is in the description.
Elements like Linux, embedded Linux, TFT, UDP, TFTP. So it starts attracting the eyeballs of recruiters and other people, right? They will say, oh, this looks to be some good project. Now you go into the interview. They ask this question, what will you do?
Am I audible, sir?
See, the thing is like, okay, without a technical thing, like basically, how it gives is like based on priorities. We'll have a function called priority. So based on the priority, it works. So who gives like an like like an stack and queue method, like which one comes first, which which one is asking, like which user is asking first will get response first.
Okay, sounds good. Let us say you went to your hostel room. You did not even remove your shoes. You did not change your dress. You opened the laptop and you started uploading. Let us say you did that. But the file size itself is 500 MB, 800 MB, something like that, right? So there are multiple students who get into their room and they start doing the same thing.
But even Vamsi, okay, when everyone does it, but everyone can't do in a same second, right? Everyone will
Okay.
not do it the exact, yeah. So even 1 second, 0.5 seconds will be a difference that they will give priority, like no, yeah, the system will give priority to the first comer actually.
Yeah, first come first serve algorithm. It's there. Like OS already implements that one of the scheduling kind of process is first come first serve process, right?
Yeah.
So it does it. I understand. So now what is the drawback of first come first serve? Now let us say your file itself is taking time to upload. What about others? What about professor? He wants to upload mark sheets. And he's saying, what is happening here? He might be entering through a different network, but it's finally the same server, right?
Yes.
Yeah, Chiranjeev, I think this might be much more common to you in the university that you are studying in US. You might have faced.
Yeah, yes, Vamsi. Yeah.
Yeah. Okay, but I take it. What about others? See, your job is at stake. Interview question has come.
I think can we implement collision detection or collision implementation?
Collision detection, collision implementation is already being done at MAC layer. CSMA CD, it is happening, and that happens at the MAC layer. So what is TFTP? And where is the collision here? There is no collision, right?
I mean, to and fro uploading and downloading will be happen, right? So
Yeah, they will happen. They will happen. See, at any point of time, either you say, I want to write a file or I want to read a file.
yeah.
It's a read request or a write request, right? It can't be read write request. So practically here, the collision thing is not existing. Yeah, there will be an existing wherein on the same physical medium when I send and you send at the same time, the data packets can collide. Yes, it always happens. And MAC layer already takes care of it. CSMA CD is already there.
Yeah.
Carrier sends multiple actions with collision detection, right?
Yeah. CSM or CD.
So do you think it is wise to push that kind of critical operation to something like TFTP, which ideally shouldn't be, because the layers are already well defined.
Yes. Okay.
Yes.
Okay.
What should be the solution, or what can be the solution?
So the one
Still
I
we didn't give
suggested in
answer,
that.
right, Vamsi?
Now here first come first serve. So now Swaminathan, I heard his voice first. Data compression algorithms might help is what I feel. To some extent, yes, data compression algorithm, but still the number of users I can't reduce. Yeah, Swaminathan, please go ahead.
So the suggestion I gave, like, so we are doing stop and wait, right? Like we send one packet and we wait for acknowledgement. Instead of that, like we have like we accumulate few number of packets and in a window, like we had a discussion some time back, right? A couple, let's say n is the window length, and then based on that, we give a combined acknowledgement instead of one acknowledgement per packet. So that can, reduce the load on the network. At the same time, one option from the I
Hello?
can save the file in. Hello.
Yeah, in between, I something got missed.
Yeah.
So I
Yeah.
understood that you can have it's not single window, but a window of size n is what you are saying.
Yes. Yes.
Okay. Yeah, that is an option. That is definitely an option wherein you are saying that I am taking care of maintaining the state of my operations. Like I have sent 5, so I am waiting for I have a repository of 5 wherein I know that all the 5 have reached. So I clear off this thing and I again send 5 and I store 5. So the window is always full. Yeah.
Correct.
Okay. Okay, I buy this option. But this is what your decision that you are taking from the client. So the server also should be aware of this, right?
Correct. Correct. Yeah.
Yeah. So what other thing can be done?
I think increasing block size only can benefit to some extent. I don't see much benefit in increasing block size.
Okay. What is the benefit what is that some extent of benefit that you are seeing?
I mean, increasing block size, I see that, okay, the client and server, they have to increase their buffer size. And I mean, to what extent? I mean, it is endless then. Like we keep increasing based on our size, data size, right? So maybe we keep that uniform and we improve the overall protocol, like, different type of acknowledgement, etc. But yeah, increasing block size can be considered as a trivial solution. I mean, the immediate solution.
Okay. Okay, one is increasing the window size of the number of packets that got transferred, and I want acknowledgements to be received. And the other option is increasing the block size. Okay.
There
Along
are
with increasing the block size, there is some other parameter. If you increase, you can bring. See, you said that the increasing of the block size can go indefinitely because the client can be very greedy and say that no, I want to send first 1 MB, then it can, I mean, I can say, let me send 1000 bytes. Now it can say, it can become greedy and say that I can go for 1500 bytes, is what you are saying, right?
Can we change if we are able to change the port per request? For example, one user is using one port of the server, another is using another port. So I think this can be scaled, but again, I'm not sure.
Yeah,
At least it will.
it's like same ground. You are saying that the
Yeah,
ground is
yeah,
already
exactly.
full of people. You are saying that, okay, let me enter from this gate. Okay. So this is the solution. This is a problem that people found when they started using TFTP. So our man Swaminathan, whatever he told, they actually did that solution only. That they increased the block size. Rather, I would not say they increased the block size. They actually told the client that you very well know what you want. You very well know what is the size of file that you want to upload. You very well know what is the size of the file that you want to download. So why don't you tell to the server that can we negotiate a block size? And because you know you are increasing the block size, why don't you also go ahead and negotiate the timeout value also? Logical, right? Because you are going for more amount of bytes to be transferred, and it takes time. If you have the old timestamp or old timeout, it may always timeout in the mid of the transfer. Are you people clear with what I am trying to say?
Vamsi, when increasing the block size, it increases the capacity. But we were talking about the priority, right? Like which one, like when many people ask request, who will get a response? So when increasing the block size will increase the capacity only, right? It doesn't give any priority to like who asked first will get the response first. Yeah.
Yeah, it's true. I take your point. See, let us say at 4 o'clock, the school time is over and the children have to be sent to their homes. One of the routes, the bus that has to go in one of the routes suddenly broke down. So the children who are supposed to go in that bus are now put into another bus. The block size has increased. How does the priority change now? So I'm going in route 1. I will go in route 1. Then again, I will take U-turn or something and I will go in route 2. That's where I'm saying, because see now, because what is happening is, if I understand the round trip delay of this particular bus now from the time T1, now T1 will be more than yesterday's T2, which is the time by which that bus reached. Now it will be more than T2 because it has to go in route 1, it has to go in route 2, drop the children and again come back to the campus. So if I have a wall clock, I will say that, okay, half an hour, everything should be done. Now because of route 1 and route 2, it has taken one hour or 1.5 hours. That is why I'm saying, because you are increasing the number of bytes, which is you negotiated the block size, you also need to ensure that the timeout is also taken care. Don't timeout with the previous timeout value. That time it was only 512. Now I am sending 200 bytes or 2000 bytes. So the timeout proportionally has to be increased, right? Guys, is this clear?
Clear
So
also.
the more timeout it takes, and while it is processing the request for the user that has.
If you want to work with me personally, where I guarantee to work with you until you secure a well paid job, book a one on one call with me. Link is in the description.
A large file, how can it help the user that has a small file and he needs to spend? Because if the large file is taking all the time, it doesn't free up actually bandwidth to someone who just needs to come and just upload a small file and go.
That is already there, but it is better than the previous situation where everybody is suffering, right? Clear?
Vamsi, a small thing, like I will just say what I understood actually. So the thing is like so many users will give request. So as like when node 1 is full, so it will go to node 2. So when we increase the timeout, the node 1 will go into node 2 and the block size will increase, and then the information. So that's what you're saying now, Vamsi, at the end. So
Okay. You literally prepared a cocktail now. You literally prepared a cocktail. Okay. I was giving an example of multiple users. It could be only you. It could be only you, the user, but still you know that, oh, this file is too big. And I can't sit for 1 hour, 2 hours just to upload this file. In that case, what will you do? Now there is no question of priority. There is no question of so many people. You are the client and there is a server. But you will save your time by putting extra load on the protocol, which in turn will put on the network, which anyways can do. See, your 512 bytes actually is nothing for the data packet. So you make it 2000 or 3000, tirelessly it can actually go and transfer it. So your time has now decreased. Your time effectively has decreased, but the protocol timeout value has to be appropriately increased. Because earlier 512, if that is not reaching within the certain time, I timeout. Now it is 2000 bytes, so proportionally it has to increase. Is it 3x, 4x? Yeah, that's a different thing. Making sense? So what I'm trying to tell now is, if you really treat technology as something that is by your side and you start narrating a story with some context and trying to do some and trying to find solutions in that story, like a detective when you start observing the corners with a magnifying glass. Coding in the sense trying to solve a problem is not really so difficult that people actually attribute to it. How many of you understand this? And I'm again saying, and I will say this any number of times, and it all starts with your writing that essay. Every time you write that essay, you have something, you travel that process and you come to you come to a conclusion and you start writing the code. You feel something is happening. Again, you go back to that essay and all those things. You are done. Your problems are very easily now solved because that same text that you have written will transcend back to the diagrams, the use case. Again, you come here again before pseudocode. Again, you go to the TDD and you can do it. Yes, the complete process may not be always needed, but at least at the ping ponging between TDD and your code will now become very effective. So at later point of time, you can go and improve your essay and all those things. Making sense? So this is what exactly people have done. And they created a, I don't know what it is called, some enhancement or refinement, you call it anything. And they have done that. So let me share. Yes. So this is where they started this negotiation of block size and timeout extensions. So this is to enhance the TFTP server so that these kind of problems can be solved. Now for that, remember once I told that the last error or if you write an enum, the last value we normally keep the same. I mean, when I say value, not the value as such, but the string that we say that the last underscore error or something. So in the same way, what these people have done is they have just extended the kind of errors and they have extended the opcodes. So to cut short, this is called RFC 2347. It is an option acknowledgement for negotiation before file transfer begins. So let me first share even this also, then it will make more sense. If I show this diagram, then it will make more sense. This is the document RFC 235 or 2347, and this is the diagram. Okay, even before that, I want to show this diagram, not diagram, but yeah. Okay, this is the text. Okay. So how the packet becomes is you have an extra opcode which is optional acknowledgement. For example, for read or write, you send the file name, you send the mode as ASCII or something, then you start appending the optional values. Option 1 null terminated, value 1 null terminated, till you can go for option N with value N. When you create this kind of packet, this is an extra packet now. When you create this kind of packet, it's the same thing only here also.
I think you are sharing some pictures, so we are not able to see.
Okay, did I not share? Okay, let me share the complete screen. Sorry. I think now it is clear, right?
Yeah.
Sorry. So this is the packet. This is called optional acknowledgement packet. So you have the optional acknowledgement. This is an opcode, extra opcode, okay? In the list of opcodes like data, error, acknowledgement, write request, read request, this is an extra opcode. File name, null terminated, mode, null terminated. Now comes option 1, null terminated, option 1 ka value 1, so on and so forth, till option N and value N. So this is how you create the optional acknowledgement packet. So let us go what happens. Now, when this happens, in the sense when the client says that, okay, I have a read request now, but I want to read more number of data, or I can actually go and read less number of data also, less amount of data. So when the client appends options to the end of the read request packet, 3 possible responses may be written. Okay, not this, sorry. This diagram. Yeah. See, this is the read request. So client is sending first read request, file name, null character, mode, null character. Now the option 1, block size. So it's a literal. So now this string is not case sensitive. So the server will understand even if you put it in caps or alternate caps, doesn't matter. It understands that it is block size, null terminated. Now the block size has been changed from standard 512 to it changed to 1432 bytes. So this is the read request because the first opcode is read, for which now the server is sending back optional acknowledgement. Now the optional acknowledgement opcode is now 6. Now we know that when the server is sending back the acknowledgement, it normally sends the acknowledgement opcode and it sends the block number. You people remember that? It's very tough to actually, if I don't see your expression, it's very tough to see black boxes and understand. So as an acknowledgement, you send the acknowledgement packet along with the block number. Same strategy is extended here, just that here we are sending the optional acknowledgement and I am saying that, okay, I accept whatever block size you are saying. Because ultimate decision of whether to accept or reject is from the server side. So now there are 2 cases. Server can accept and server can reject. Now when the server rejects, there is one case, and the server accepts when there is another flow of action, and we will come to that. But before that, let us go in the positive direction that the server is saying that I am okay with it.
If you want to work with me personally, where I guarantee to work with you until you secure a well-paid job, book a one-on-one call with me. Link is in the description.
Now the client says, great, this is the read request. So server is saying, I am okay with it. Then the server is responding back now with the acknowledgement, and it is sending the first block number 0, which is an intention from the server saying that, intention of the client saying that I want now the block 0. If you see, this until here is same as standard read request. This is also standard read request. We sandwich this optional acknowledgement here. That's why this is called optional acknowledgement, which starts before the actual data transfer and immediately after a particular request. So it's so how do I know, or how does the server come to know that the client accepted, or client came to know the acceptance from the server is this step, that it sends the acknowledgement with 0th block number for read request. Then the server will start sending the first block with the 1432 bytes of data. And now from here, it is standard read request, except that the block size is now not 512, but 1432. Clear? Any confusion here? Now come to the write request. Same. 1 is the read request opcode, 2 is the write request opcode, file name, null terminated, octet, null terminated, block size, null terminated. Now the write request is I want to write 2048 bytes and null terminated. server again is sending back. Now this is a write request for which the client is directly responding with the data. It is not doing anything saying that, oh, okay, good, I understood that you accepted. It is not giving any, see, this is a trigger for the server to send the data from its side. But if you see, this itself is sufficient for the client to understand that the server accepted. How many of you understand this small distinction? In the read request, I have to explicitly tell to the server that, or I have to explicitly tell my understanding that the server accepted my request somehow to the server. That's why I have this 0 thing. But in the write, I don't have to tell. This optional acknowledgement is equivalent to the actual acknowledgement. I don't have to separately acknowledge. Bhai log, why or Veno? Making sense? The only difference is this optional, after optional acknowledgement is this thing, because I need to tell here the server that, oh, I understood that you have accepted my negotiated value. But here, this itself is an acknowledgement. When the server sends that I'm okay with the block size, I'm directly sending the negotiated value. And
So the
from
special acknowledgement works like a normal acknowledgement in the right case. The special acknowledgement works like a normal acknowledgement in this case.
Exactly. Just that instead of the block number, the first time I'm sending, it is not actually the true acknowledgement, it's an optional acknowledgement. That's it. In the write request, it's very clean. The optional acknowledgement is just somebody who is coming to tell the client that server is okay with the negotiated value. And from there, continuously the transfer starts. But here in the read request, client should tell to the server that, okay, I am happy that you accepted my request. From there again, the normal process starts.
Sir, is that acknowledgement for read request from the client after server accepts, sir? Is it mandatory, or is it part of the protocol? It's like, or it's optional?
No, it is mandatory. Otherwise, how will the server know that the client has received its acceptance?
Okay, because I got confused, like, because both are like read and write, the request is coming from the client. Then if the server responds, then that itself should be indicating, right? Indicative acknowledgement, right? Why do we need a separate acknowledgement for read case?
What you are saying is when I send this optional acknowledgement from the write request, here I am directly transferring.
Correct.
What you are saying is if I am sending it from here, why is that the client not saying that, okay, I can read that much amount of bytes, right?
Yeah.
Yeah, you tell me that the diagram is here. Who has the data here now? See, here client has the data, so I know that 2480 is okay for me, and I will send off 2480.
Okay. I got it, sir. I got it. Yeah.
Yeah. Because somewhere I have to tell to the server that, okay, now you start sending me, right? And that
Right.
start firing is here.
Got it, sir. Yeah.
Yeah. Okay. Yeah. This is very important because this is TFTP, because this is UDP, these kind of considerations are important. And this is what is the, how should I say? This is what is one of the few questions also you might have got when you are implementing that TFTP protocol has no security mechanism. That is why it has no rename, delete, or file override capabilities. And that is the reason why in our implementation also and in the RFC also, when you send file name again, you get an error packet. if that file is already existing. Remember, one of the error codes is file already existing. You are not allowed to rewrite, or you are not allowed to overwrite, because it has no security mechanism. So this document does not add any security to TFTP. However, the specified extensions do not add any additional security risks. Clear? So there is only one place that you need to now understand. Depending on the original transfer request, there are two ways for a client to confirm acceptance of server's OAC. If the transfer was initiated with a read request, then an ACK with the data block number set to 0. We have already seen that. Is sent by the client to confirm the values in the server's optional acknowledgement packet. If the transfer was initiated with a write, then the client begins with a transfer. Okay. Where is the error condition? Somewhere. If a server implementation does not support optional negotiation, it will likely ignore any options appended to the client request. So the point here is very simple. If the server accepts it, it is fine, and it will respond back as an acknowledgement whatever options it accepted. If you have sent 3 options, and the server is okay with only one, then it will acknowledge only with option 1 and value 1. It will drop off option 2 and value 2. And when the client sends it that, when the client wants to operate with those options, they are no more valid. Only option 1 is available for the client, because it is at the server's end, or the capability at the server, that it says that I agree to this or I don't agree to this. So in this case, the server will return a data packet for the read request and an ACK packet for a write request, establishing normal TFTP data transfer. That's it. Because the client has sent options doesn't mean that the server has to agree. It will agree if it wants to, else it will not agree. In the event that a server returns an error for a request which carries an option, the client may attempt to repeat the request without appending any options. This implementation option would handle servers which consider extraneous data in the request package to be erroneous. Making sense? Any question here? And this is one last paragraph that I want you to have some observation. Once a client acknowledges an optional acknowledgement with an appropriate non-error response, that client has agreed to use only the options and values returned by the server. Remember that the server cannot request an option. It can only respond to them. If the client receives an optional acknowledgement containing an unrequested option, it should respond with an error, with error code 8, and terminate the transfer. Like, I want to draw your attention to this one point. Just 7 pages document, and the last 2 pages are useless. The last page, at least, of course, is useless for our understanding. And the first page is also not so much. Introduction is very simple, which means within 5 pages, they were able to compress and write such a valuable information that reading this text, somebody can actually go and implement a piece of code. How many of you people observe this?
Sir, I have one doubt, maybe trivial, but so we have regular read request with 512 bytes. And so OAC, there's a new operand which for read request and write request. So you're saying that itself is modified into that.
If you want to work with me personally, where I guarantee to work with you until you secure a well-paid job, book a one-on-one call with me. Link is in the description.
Operand, right?
No, the TFTP protocol got an extension for those cases where we are giving certain capabilities to the client, wherein it can negotiate certain parameters of the data transfer, subject subject to the fact that the server, if it wants, can reject or accept. The other aspects of the protocol are not touched.
Okay.
This is only an optional thing. And that's where this text also very clearly mentions that in case the server is not capable enough to address or understand any options, it will not do anything. It will just step into the proper vanilla TFTP transfer and then start doing the operation.
Okay,
Yeah.
sir. Yeah.
Okay, now let us look at the code. Yeah. Same question. We are following the same template. Why parse options at the beginning? Fastest button first. Fastest finger first. I think I don't know what to call it. Why parse options at the beginning?
SCRT, the function works like that, right? First you have to give the string, then you have to give null to again continue with the parsing and get the values.
Yeah, that is true. I'm not asking about the capability or what is being done in the parse options. Why is that when I started writing, I first went and I wrote this function.
Because there's a new operand and the request we need to differentiate.
Okay, so what? Why did I write? Why is that I did not write this function? Why did I start with this function, which is handle request or parse options is here? Why did I not start with handle request? Why did I write with parse options? Test-driven development. Getting the point? Harsha, Swaminathan.
Yes.
First, I send a packet with options. It fails. I am a client. I send file name, opcode, file name, null terminator, mode, null terminator, then option 1, null terminated, value 1, null termination, and I send that packet. Then I get a failure. Right? Or in this case, because I'm implementing from the server side, I hard code that kind of information to the server. Then the server code fails here. Then I say that, oh, okay, now I need to handle those options. Now handling options is nothing but parsing those options, right? I can write handle, but the top level function is handle request. Inside that I am parsing the options. Can you see the naming also of the function? So this is simple string tokenizing function. I'm saying I go until this, then I get what is the block, what is the string. If it is block size, then whatever is the value, I am converting into integer and storing it. And then if it is the second option and I compare it with timeout, yes, then I take out the timeout value. And I repeat till it is not null, so that I can go for option 1, option 2, option 3, whatever. Simple. This is simple parsing of a string. Handle packet is just making use of it, parsing option. And in case I agree, I am sending it. That boss, I am happy with this. You can go ahead with the operation. And the client does the normal operation. This is normal read request, write request, and then handling the request. Internally, I am parsing the thing also. Any questions? There is not much big in this code. It is a very simple extension of whatever the code that you have, with very important enhancement with parsing the options that are sent by the client here in the server. That's it. Any questions here? Harsha, Swaminathan, Chiranjeev, Yash, Leela Prasad, Chandrika, Anirudh. Got the idea? Okay, yeah.
Sir, hello.
Yes, yes.
In case that server says that the block size it can't handle, or any case that it rejects the request that we made, so we should be handling it in a different way, right? Like we have to negotiate, means again we need to have some kind of loop back mechanism that can handle decreasing the size of the block or something like that, so that server also will be okay with it.
Okay, I got your question, but this is what I want to say. Can you rephrase your question so that others also can understand it more clearly? I understood your intention, but I want you to rephrase the question for the benefit of everyone.
So what will happen if server will reject our request, saying that it won't? I don't think there is a lot of info will be given by the server if in case it rejects, right, the request. So what is generally done, or is there any standard way that is handled by the clients?
Okay. The answer is there in the thing we already discussed, but I will extend a little bit whatever you said in and around that, and we will come to this question. So the first thing is, this is a request by the client. So the server has freedom. In fact, the server is super capable, or it is the.
If you want to work with me personally, where I guarantee to work with you until you secure a well-paid job, book a one-on-one call with me. Link is in the
Supreme
description.
power to say that I accept or I don't accept, right? The first thing is that. Now your question comes, what if the server does not accept this? If the server does not accept this, there will not be any optional packet, right? Optional acknowledgement. Which means the client would have sent. Okay, let me share the screen, then it will make more sense. And for that, I need to open RFC. Oh no, I need to open RFC. Yeah. You need to see this. Where is this? This. Yeah, see here. Is the screen visible, Harsha?
Yes, sir. Yes.
Okay. Now, we will come to the case where the server rejects, or the server says that I am not in favor of whatever the negotiation you are doing. I don't understand your options and all those things. Which means this is as per the standard protocol opcode. Read request packet format. First is opcode, file name, null termination, mode, null termination. 4 bytes beyond the data. Now it has sent these. If the server has not accepted this, it will not send this. It will not send this.
Yes.
Then I will not do this. Then this will not be there. Then I directly start from here. Because think from the client side. Server is sending. The code that you have seen is the server code. From the client also, you have to parse, and you should understand that, okay, the server has agreed to mine. So what is missing here, which is making you to ask this question, is the client code is not there. The second part of the equation, which comprises of this complete communication, is not present. What you have seen, the code is from the server, just parsing and understanding the options that the client requested. If I don't do it, how should the client respond? is the client-side implementation. But the obvious implementation from this packet exchanges itself means that, and I am not saying that, okay? I am not saying that. It is mentioned here. If the server implementation does not support option negotiation, it will likely ignore any options appended to the client's request. In this case, the server will return a data packet for the read request and an ACK packet for a write request, establishing normal TFTP data transfer. Did you get the answer?
So we have to check and handle it from client side. Yes.
It is always on the client side. It is always on the client side, right?
Yeah.
You call somebody by a name, and that person, instead of taking your name, he starts scolding you. Now you will go and hug him or you kick him is a decision that you have to take. Yeah?
Yes, sir. Understood.
Yes. See, this is why you need to go and read RFCs. It will teach like in few words, how can you write a very good technical document where in the sense there will be no ambiguity. In case if there is any zone, any area that they want to tell to the implementation, or they want to put the control in the implementer's domain, saying that you choose what you want to do, those things are also very clearly mentioned. Reading RFC will enhance your understanding of understanding of the protocol and all those things, but also it will develop a skill of how to precisely write good technical document. A skill that no college teaches, we don't learn, we never get a chance to learn. But intentionally, you have to take these kind of steps to enhance those skills, because these kind of skills actually differentiate you from other people. And when you read an RFC and then you get into the code and understanding how it is implemented, you will become a person who can even you can do a better code reviews. You will do a better review of requirements documents, anything. You will become that person where other people will come for help. Not because they can't do, but because they did not intentionally develop those skills. And they even do not know. Even I was not aware that reading an RFC will give so much. My team leader once said that if you don't read RFC, you are not worthy enough to be in this company. I told, what is this, man? Itna bada baat bol diya. You can solve any bugs, but if you don't understand RFC, you will be just that person at your level, or even after 5 years, just fixing the bugs. But if you know RFC, you will talk at a different level altogether. Any questions? We are on time because these are all short code pieces, but very critical enhancements.
Yeah, actually, I have a doubt.
Yes.
Can you tell me once again how does the block size negotiation happens between the client and server?
Okay. So the block size negotiation, this is only block size. Okay, there are two more there is one more RFC. This is actually talking about the negotiation of code. There are two more RFCs which will talk about the actual block size negotiation, how it happens, and also, yeah, see, this is timeout interval and block size option. These are the another two RFCs that you need to read. But yes, understand that the block size negotiation or the intention to increase the block size beyond 512 is a decision that the client has to take. It's a वो client की इच्छा है. Client चाहता है कि मैं ज्यादा भेजूं. That is why it is sending along with its read request an option to the server saying that I am interested to send not just 512 bytes, but more than that. In the same way, it is also telling its intention to the server that I am interested to read more than 512 bytes. Can you send? See, this question here, this number 2048, या कुछ भी हो सकता है यहाँ पे 1432 is a question from the client to the server saying that, are you okay with this? Okay with what? With this block size. For which now the server responds, yes, I am okay. This is a case of I am okay. And here also it is a case of I am okay. After which we fall down to the standard, precisely here, standard read operation, and here the standard write operation. And you see the finally, after everything is done, we are sending the ACK. Clear? Any doubt here?
No, clear, it's clear.
Clear, right?
Yes.
Okay. So any more questions? Please let me know. We don't carry those doubts along with you. Anirudh, Ananda, Chandrika, Leela Prasad, Chiranjeevi, Swaminathan. Yeah, Swaminathan, any question? Share the RFC doc or the RFC code. Yes. Yeah, I'll do it. I will put the RFCs. Yeah.
No, sir. No.
Okay.
No, sir.
Yes. So let me stop the recording.
If you want to work with me personally, where I guarantee to work with you until you secure a well-paid job, book a one-on-one call with me. Link is in the description.